Hi, hello everyone. So for my random sampling, I chose to look at the 2018 NBA All-Star Game starters for Team LeBron. This is of course only 5 players. Of those 5 players, I will randomly select 3 players for each trial. And of those 3, I will count the number of players that have won MVP over the span of their careers. So just for a reference on my data, 2 out of the 5 starters on Team LeBron have won MVP at least once. Those 2 are Kevin Durant, who's won the MVP award once, and LeBron James, who has won it 4 different times. Although that won't make any difference in the data. So for the first sheet I have here is all the different possibilities. As you can see right here, there's 10 different possibilities. So in this table right here, I have the probability of drawing 0 MVPs, drawing 1 of the 2 MVPs, and then of course drawing 2 of the 2 MVPs. So the probability for drawing 0 is the smallest, and that is 10%. The probability of drawing 1 MVP is up to 60%. That is the highest. And to draw both of the MVPs is at 30%. So down here I made that histogram. I figured out the expected value, which is this arrow right here. I also have the standard deviation represented by these 2 lines right here. So to figure that out, all I did is I multiplied number of MVPs by the probability, then added the sum of all those numbers up, and that is how I figured out the expected value. Standard deviation was of course a little bit trickier. So for standard deviation, I had to find the difference between the expected value and number of MVPs over here, which was really simple. It's just basic subtraction. After you figured that out, I just squared those values of the differences. After you squared the differences, you multiply the squared numbers by the probability, and then just add those up. As you can see here, I got to 0.36, and then from there, your final step is take the square root. I don't know what I'm doing here. Take the square root of 0.36, and that's how I got 0.6 as my standard deviation. Hopefully you're able to follow along with that. So here's my empirical data. So these are actual results from just completely picking, if you will, it's like picking 3 of the 5 names out of a hat, I suppose. I used the lowest values out of each trial, and I counted those as I said earlier, as the 3 names you would draw out of the hat. I highlighted those yellow here, and all the way down, I did a total of 50 trials. I also highlighted Kevin Durant and LeBron James' name because they are the MVP winners that we are looking at. So over here, of course, I have the trial number and then how many MVPs were chosen out of each trial. I recorded the data there in that little table right there. And then over here, I actually figured out the probability of each one of drawing. So if you notice, this histogram looks a lot, I'd say a lot different than the last histogram. So the value 0 is about the same. So on the last one, if you remember, it was 10%. Here it's 6%, so not a huge difference. What I found kind of fascinating is how different 1 and 2 are. So 1 on the last chart or histogram The probability was 60%. I'll flash back real quick. 60%, as you can see here, and the probability of drawing 2 MVPs was 30%. But that's a lot different on this, or from this data that we gathered, where drawing 1 is 50% rather than 60, and drawing 2 is 44% rather than 30%. So our charts obviously look a lot different. 2 is obviously higher, and 1 is obviously lower. The standard deviation remained the same. To calculate that, it's exactly what I did before, what I just explained. But the expected value, as one would expect, 1.38 is higher than 1.2. This, of course, makes sense because the likelihood that when we drew 2 MVPs, that number was higher on my empirical data here, 44%, than it was on the expected data, which was only 30%. So hopefully you were able to follow along with all that. I know I didn't explain standard deviation the best, but all I did is I watched Professor Barron's videos, and that's basically how I did it. So if I confused you in any way, I'd highly recommend looking at the examples.